Hi, in this video, we are going to see how we can perform a streaming transcription on speech to text. Now, what is streaming transcription? In my last video, I discussed on batch transcription. So you take a audio file, you feed a audio file to a speech to text model, it transcribes the entire audio at one shot and give you the output. If you're not seen the video, you can click the link on the top and watch it, or the link is also in the video description below. When we talk about streaming transcription, these are basically typically used for your real-time transcription. Say you want to upload an audio and kind of convert it into text, but the audio is around 1 hour of play or 20 minutes or 30 minutes. Typically, the speech to text process will take around 20 minutes or 30 minutes to do it, and you don't want to wait that long. So that's where streaming transcription comes into play. What you can do is you can upload the audio, you can buffer the audio in chunks and then feed the chunk into your speech to text transcription and only transcribe a part of it. So as the audio is kind of getting converted, you can see the output in real time. Streaming transcription is also applicable when you're talking on a microphone and you want to immediately convert the speech to text output. So typically in a conversational AI system, when you're talking like, okay, Google, put me the maps. So as you're talking, if you want to understand, if you see like, okay, Google will start typing it. So you want to do the transcription real time, and there also the streaming transcription comes into play. So let's get started with the video. I would recommend you watch the batch transcription video, which I mentioned earlier, and it's the YouTube description, but if not as well, it's fine. Some of the concepts I will cover it and show the difference where the streaming transcription and the batch transcription differs. So for this video, what I'm doing is I'm installing some of unique specific libraries, LibaSound, Port Audio, which are like prerequisite for your Deepspeech. And then I am installing Deepspeech, which is the speech to text package we are going to use. I have covered Deepspeech as well in a separate video, but to give a quick gist, Deepspeech is basically Deepspeech is basically an Baidu open sourced package. They use an end-to-end deep learning model to train an acoustic model, and apart from acoustic model, there is a language model as well to improve the accuracy of the output. So that's what I'm going to do. I've already installed Deepspeech. And if you see over here, I am downloading two different files from Deepspeech website. One is the PBMM file, which is nothing but the acoustic model, and this is the end-to-end deep learning library I was talking about. And you have an scorer model, which is nothing but your language model. The language model works on top of the acoustic model output to increase the accuracy of the transcription. So these are the two files. I have already downloaded it. Now I am importing a Deepspeech library. I'm importing the model function from that. I'm importing NumPy, OS, Wave, and JSON I'm importing, but I'm not going to use this in this particular video. And then I'm having like IPython display audio to play the audio. So let me run this. Then I am assigning multiple path. I am assigning the model file path and the language file path. Now this is the files I downloaded on the top. So I'm telling this is my model file, this is my language model. And then I have multiple parameters that are set. The LM alpha and LM beta for the language model. And this is taken from the Deepspeech GitHub repo. This is the best parameter they have published over there based on the hyperparameter search when the model was trained. But you can tune this model to see how you are tune these parameters to see how your transcription performs as well. The beam width is another parameter. Now beam width is basically tells you how many different word sequences will be evaluated by the model. So if you have a beam width of 500, maybe 500 word sequences will be evaluated to find the best probability out of it. If I have given 100, it's going to evaluate 100 different word sequences. Now the more you give, the more better transcription you may get, but it also increases the processing time of your end transcription. So these are the parameters, and then I am calling the model object which I imported on the top and sending the model file path. And once I have the model object, what I am doing is I am enabling an external scoring component for the language model and giving the language model file path. So I have run this. Now next what I'm going to do is I'm going to also set the parameters that I have, LM alpha and LM beta for the scoring model, that is a language model, and beam width for your entire acoustic model. So let me run this. Now this is where this is different from the batch model. So in the batch model, what we do is we read an audio, we took the entire audio into buffer and sent it for transcription. Here what we are going to do is we are going to create a stream. so that as the audio is read, we are going to take chunk of the audio and then send it for transcription. That's why I'm creating a stream object here. So I'm doing a model dot create stream, and it will give me a stream object. And after that, I'm creating two functions. The first function is to read the audio file that I am sending. So I am sending the audio file. I am getting the frame rate. What is the frame rate of the audio file? What is the number of frames in the audio file? I want to know how many frames are there, so that I can kind of iterate and buffer the audio for that particular final frames. And then I'm getting a buffer where I am reading the I'm basically taking the frames and then reading the frames and keeping it in a buffer and returning buffer and rate. This is one function. This is nothing but just reads an audio file and sends a byte array of the audio file, and also what rate it is. Right. The next thing I'm going to do is I'm creating one more function called transcribe. In this case, transcribe streaming, because I'm going to transcribe as it is getting streamed. I'm passing the audio. I'm calling the top function read wave file. I'm passing the audio file and it returns me buffer and rate. And I'm setting some of the parameters. In this, what I'm doing is I am basically checking my offset. Right. So I'm starting from offset 0. I'm checking less than length of buffer. So my buffer is nothing but the audio byte array. I'm checking the length of the audio byte array. If it is less than audio byte array, I'm iterating a loop. And in this loop, what I'm telling, take a batch size of 8196. So I'm taking batch size of 8 KB of the audio every time and transcribing it. That's what this batch size is. So if you see over here, what I'm doing is I am taking the offset plus batch size. That is the first 8 KB. Read it, and then I am taking the buffer object which has the audio, and I am passing the starting offset, that is 0 in this case, and then the end offset, that is the 8 KB for me. So I have to read 8 KB chunk. Once I have this chunk size, I am passing it to the numpy array from buffer. So if I am doing a batch audio, what I'm going to do is I'm going to pass the buffer directly into this from buffer object, right? But in this case, I am taking only a portion of an audio to transcribe every time. So that's why I am sending it to numpy.from buffer. And then what I'm doing is I'm telling like stream.feed audio content. Basically, I'm whatever data I got, I'm passing it to it. And then I am telling like stream.intermediate decode, which will decode at the step, in this case, a set of stream object of 8 KB buffer. It will decode it and give the text. I am printing the text. Now this is something I have commented out. If in case what will happen, like it will keep printing one after the other, and you can see a lot of duplicate data. If you want, you can just clear the console out and watch it, but I want to show you how it looks like. And once the first 8 KB is read, I am sending my end offset to offset. So my top again will come 8 KB plus again 8 KB. That is the 8 KB to 8 KB, right? It will buffer the next 8 KB, next 8 KB till the end of the audio. So that's what I'm doing, and it's returning true. Once I have done with the transcription. So this is run. I'm going to download an wave file from the Deepspeech repo, which is nothing but a man1_wp. I'll show you what it contains, and I'm downloading it as speech.wave file. And let me run this. And if you see if I list the directory, you can see basically I have the speech.wave. I also have the PBMM and scorer I downloaded. Now let me take and play this audio file. So that's why I'm calling this audio object, which is IPython library that I'm using. So let's listen to the audio.
In the course of a December tour in Yorkshire, I rode for a long distance in one of the public coaches on the day preceding Christmas.
Yeah. So this is a very short audio that I have. Right, this is a very short audio that I have. Now what I'm going to do is I'm going to take this audio file and call the transcribe streaming function, that is and pass this audio file. That's what I'm going to do. So now once I run it, you can see rather than waiting for the entire file to get completed, it will do it. Just a minute. I think I did not run one more function on the top. Let me go and run the read wave file. Yeah. And then now let me call this a transcribe function, and now you can see, like, rather than see as the audio is getting spoken, basically it's trying to run it and it's printing the output. So if you see over here in the course of December, but because it has only taken part of the audio, it is trying to guess the word. It's guessing it as dice, not dis. because what will happen, the acoustic model will correct it and also the language model will correct it to see what is the probability of the right word over there. But as I'm getting more buffer, it is trying to interpret the words properly, and finally you can see in the last one it is printing the entire word that we saw in the audio. So basically the streaming transcription is pretty much applicable in cases where you want to record from a microphone, or you have very large audio file, you don't want to wait, you want to see the output as soon as the transcription is happening. You can use the streaming transcription function. Thank you very much.